Module 7 review. We'll start off with 7-1. It says solve each polynomial equation by factoring. All right, so let's factor this. Let's factor it. So we have 4x cubed plus x squared minus 4x minus 1. So let's see, 4x cubed plus x squared minus 4x minus 1. All right, to factor, well, first off, how many factors are we going to need? Okay, well, the question is, the answer to that is, what is the degree? And if you'll notice, the degree is 3, and we get that right here. That's the degree. Degree is 3. Something else, there's something called a leading coefficient. Leading coefficient. All right, and the leading coefficient is 4. All right, and that's that 4 right there. All right, so now let's factor. First off, we need to look and see how many terms we got. We got 1, 2, 3, 4. Okay, and really, I'm skipping one. First, what's the greatest common factor? What's the greatest common factor? You got 4, 1, negative 4, negative 1. So the greatest common factor is going to be 1. That's not going to be any help. Step 2, number of terms. How many terms do we have? We have 1, 2, 3, 4 terms. So the number of terms is 4. The number of terms is 4. So if it's 4, then we are going to use grouping. Grouping. All right, that's the easiest. So let's take a look at it. We're going to group the first two, and then make that plus, not a negative. And then we're going to group the back two. What is the greatest common factor in the first one? That would be x squared, and that's going to leave 4x plus 1 in there. All right, let's look at the back half. What's the greatest common factor? That would be negative 1. And that's going to leave 4x plus 1. Now, because we have 4x plus 1 and 4x plus 1, we can use that reverse distributive property and say that x squared minus 1 times 4x plus 1 would equal 4x cubed plus x squared minus 4x minus 1. Now we need to find, we got the factors, so to solve, we need to see, set these equal to 0. We've got x squared minus 1 equals 0, and we have 4x plus 1 equals 0. All right, so let's add 1 to both sides. You got x squared equals 1. We'll take the square root of both sides, and you got x equals plus or minus 1. So x equals negative 1, x equals 1. And then over here, we're going to subtract 1 from both sides, and you got 4x equals negative 1. Divide both sides by 4, and you got x equals negative 1/4. All right, so your last one is x equals negative 1/4. So those are the 3 solutions. Good. All right. Now, there's a couple of other ways that you can do this, and they're in the calculator. So let's get our calculator, and let's go to graphs. We'll go to graphs, and we'll graph. We've got 4x cubed plus x squared plus x squared minus 4x minus 1. And then press enter. Aha, look at there. So menu 6, 1, and that gives us our first one. That's -1, -1, and then menu 6, 1, and that gives us this one over here, which is +1. And then our third one, menu 6, 1, and let's see, and there it is. And that is -1/4. Okay, then let's check that. Is that what we had? -1, 1, and -1/4. -1, 1, and -1/4. Okay. Well, Mr. Carbono, what is the other way, the third way? The third way is to go into your calculator in Scratchpad or calculate, and then menu 3 for algebra, 3 for polynomial tools, and 1 find the roots. The degree is 3, and we're looking for the real roots. So, all right, in these boxes, we've got a 4 in front of the x cubed. We have a 1 in front of the x squared. We have a -4 in front of the x, and we have a constant of 1. Press enter, and then check 4x cubed plus x squared minus 4x plus 1. That was supposed to have been -1. Let me fix that. Delete -1. All right, good, good, good. And we press enter, and look, we got -1, 1, and -1/4. So there's 3 different ways. The first one here is algebraically, and then you can do it, and this is kind of algebraically with the calculator. And then the third way is graphically. Okay, all right. So now let's try number 2. All right. Now I'm only going to show algebraically this time here. What is step 1? What is our greatest common factor? And if you look, all of them have an x cubed in it. So you got x cubed, okay? And there's 3 terms, and x cubed is greatest common factor. So that's going to leave x squared minus 2x minus 24. And that's going to equal 0. All right, now I'm looking for some factors of 24 that when you add them would give you -2. Some factors of -24. So we got x cubed, and then how about x minus 6 times x plus 4 equals 0. -6 times 4 is -24. -6 plus 4 would give you -2. So that works. So we'll set all of these equal to 0. And then x plus 4 equals 0. So take the cube root, that gives you x equals 0. So we got x equals 0. Add 6 to both sides, that gives you x equals 6. So you got x equals 6. And then subtract 4 from both sides, and you got x equals -4. So the 3 factors are here. But hold it, this has a 5. So there's actually 2 more, but they're just x equals 0. And x equals 0. So you could say this is x equals 0 with a multiplicity. Oh, messed that up. Multiplicity. I did it again. Multiplicity of 3. And then you don't have to do those 2. All right. Good, good. Let's look at number 3. Number 3. Okay. Now, what you could do is stop this, work it yourself, and then start it back up and see. So, assuming that you've done that, assuming that you have stopped it and worked it on your own, and all right, so we're looking, we got 3 terms here. We have a degree of 5, a leading coefficient of 3. Step 1 is find the greatest common factor. Well, look, you have 3, 18, and 21. So we have a 3, and then x to the third. So 3x to the third, and that's going to leave x squared plus 6x minus 7. equals 0. And let's see, so 3x cubed. The factors of negative 7 that when you add them give you 6, a positive 6 would be x plus 7 times x minus 1. Okay, x plus 7 times x minus 1. 7 times negative 1 is negative 7. 7 minus 1 is 6, so that works. Set them equal to 0. And then x minus 1 equals 0. All right, so divide by 3, take the cube root, and you get x equals 0. Subtract 7 from both sides, and you get negative 7. Add 1 to both sides, and you get x equals 1. So we have x equals negative 7, x equals 1, and x equals 0. And that's with a multiplicity of 3. All right, good. Now let's take a look at number 4 here. We got 3 terms. The greatest common factor is going to be x squared, and that's going to leave you with negative x squared plus 2x plus 8, and that equals 0. All right, so you got x squared, and then the factors of 8 that would give you 2 would be negative x plus 4, and then x plus 2. All right, negative x, that would be negative 2x, and then 4x, yes, and then equals 0. So set each of them equal to 0. Negative x plus 4 equals 0. X plus 2 equals 0. Good, good. Take the square root of both sides, and you get x equals 0. Add x to both sides, and you get 4 equals x, and then subtract 2 from both, x equals negative 2. So there it is. X equals 0, x equals 4, and x equals negative 2. Okay. Now, number 5 is a little bit different, okay? And it says, identify the rational zeros of each function, then write the functions in factored form. Okay, so this may or may not have imaginary roots, but we're only interested in the real roots, the rational roots. Okay, so let's see here. You got, what do we got? What do we have? X cubed plus, how many terms do we have? We have 4 terms, okay? And we're looking for 3 roots. 4 terms. So I wonder if x cubed plus 3x squared plus 3x plus 1. I wonder if we tried grouping, if that would work. Well, we can take an x squared out of there, and that leaves you with x plus 3. And then we could take a 1 out of there, and that would leave you with 3x plus. That doesn't really work. Okay, that does not really work. Okay, you know, we could do this in the calculator, couldn't we? Let's see, let's go over here and let's go menu 3, 3, 1, and the degree is 3. We're only concerned with the real roots, and we got 1, 3, 3, 1, enter. And x cubed plus 3x squared plus 3x plus 1, press enter again. Negative 1, negative 1, negative 1. All right. So we've got x equals negative 1. All right. So f of x equals, and now write it in factored form. That would be x plus 1 times x plus 1 times x plus 1. Okay. So this right here, you got x equals negative 1. Add 1 to both sides, and that would give you x plus 1. All right. Now, this looks awfully familiar. Remember that binomial theorem? Okay, you got to the 3rd place there. So you did your little tree, 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. Oh, so you got 1 plus 3 plus 3 plus 1, and then you got x plus 1 here, so we got x, that's going to be x cubed, x squared, x to the first power, and then x to the 0 power. And then you got 1, that would be 1 to the 0 power, 1 to the first power, 1 squared, and 1 to the third. So let's see here, we got x cubed plus 3x squared plus 3x plus 1. Okay, so that worked, and we even checked it here. This is really your check. All right, that's your check. Let's take a look at this next one here, number 6. All right, and what do we got? Let's change it up. We have 4 terms. So let's see, you got x cubed plus 5x squared, and we'll group those, and then plus, and then negative 8x minus 48. Let's try that. The greatest common factor is x squared, and that leaves you with x plus 5. Over here, we can take a negative 8 out, negative 8, and that's going to give you with x plus, and then negative 8 into 48, that's 6. All right, we can't do this. Why? Because you got x plus 5 here, and x plus, so we cannot factor it that way there. Can't factor it that way there. I wonder if there is another way. You know, there is. Let's try, this is going to be different. Let's try the old graphing method there. On new document, no, and graph. And let's see here. What do we got? X cubed, x caret 3, plus 5x squared plus 5x squared minus 8x minus 8x minus 48, and then press it. Whoa, all right, what do we got here? Okay, so let's take a look at menu 6-1, and we got that one. Oh, that's a 3. Menu 6-1, and what? That's a negative 4. Okay. Now, this didn't actually cross the x-axis. It went up and touched it, and it went back the direction it came from. Okay, so it didn't actually cross it. So that means that this one is twice, and this one is only once. Because remember, you got a 3 here. 3, degree is 3, so degree is 3. So what do we got here? We've got x equals, and then let's see, we got negative 4, and you got x equals 3, So let's take that. X equals negative 4, x equals 3, and then we'll add 4 to both sides, and we get x plus 4 equals 0. Subtract 3 from both sides, x minus 3 equals 0. All right, remember, this counts twice. So it was f of x equals, and that's going to be x plus 4 times x plus 4 times x minus 3. And if you multiply those 3, you'll get that right there. All right, number 7. Identify all the rational roots of this equation here. So let's see, what do we got? How many terms do we have? We have, we might have to rewrite this a little bit. Okay, because you got equals 28. So let's subtract 28 from both sides, and you got x cubed plus 10x squared plus 17x minus 28 equals 0. We have 4 terms, so we'll try to, you got here and here, and then here and here. So we can take an x squared out, and that's going to leave us with x plus 10, and 17 is prime, so we can't take anything out of there. So we cannot do this one by grouping. But, you know, what the heck. Let's go back to our calculator. And And then menu 3, 3, 1. The degree is 3, and there we go. We're looking for the rational root, so we've got 1x cubed plus 10x squared plus 17x minus 28, negative 28. And let's press enter. And that looks good. Press enter again. So what have we got? We got x equals negative 7, x equals negative 4, and x equals 1. So x equals negative 7, x equals negative 4, and x equals 1. Good job. What about here? What about here? Oh man, that's kind of, let's rewrite it as 3x cubed plus 10x squared minus 27x minus 10. We'll rewrite it as that. And then we'll just graph this one. All right, so tab, and let's go up there. And I'm just going to delete it. And what do we got? We've got 3x cubed plus 10x squared plus 10x squared minus 27x minus 10. Press enter. We got 3. Menu 6, 1, negative 5. So we got, and then menu 6, 1, and then you got negative 2, or we got positive 2, then menu 6, 1, and then you got, what is that right there? That's negative 1/3. So here is our x equals negative 5, x equals negative 1/3, and x equals 2. Not too bad. Number 9. An engineer is designing a storage compartment in a spacecraft. The compartment must be 2 meters longer than it is wide, and its depth must be 1 meter less than its width. The volume of the compartment must be 8 cubic. So the volume of x is 8. All right. Now to find that, remember volume is length times width times height. All right. So the compartment must be 2 meters longer than it is wide. So W equals the width, and then the length is 2 meters, so that's going to be 2 meters longer, so that's going to be 2 plus W, and its depth or height must be 1 meter less than its width. So the height is 1 meter, W minus 1. All right, so let's see here, and we'll let x equal the width. All right, so that's 2 plus x, and then we'll make that x minus 1. So let's see, what do we got? We got x times x plus 2 times x minus 1 equals, and then 8. All right, so x times x, that's x squared plus 2x times x minus 1. And then we'll subtract 8 minus 8 equals 0. And then x squared times x, that's going to be x cubed minus x squared. And 2x times x would be plus 2x squared minus 2x minus 8 equals 0. We can combine those, and that gives us x cubed plus x squared minus 2x minus 8 equals 0. All right. So write an equation. So the volume of x, the volume of the compartment, we'll just call it x, equals x cubed plus x squared minus 2x minus 8. And okay. We'll take that off the end there. List all possible rational roots. Well, what are the factors of 8, So you got 8 over 1, and that's going to be plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, all over plus or minus 1. So plus or minus 1 over 1 is 1, plus or minus 2 over 1 is 2, plus or minus 4 over 1 is 4, and plus or minus 8 over 1 is 8. Use synthetic division to find the roots of the polynomial equation. Are the roots all rational numbers? So let's try that. Okay, so we got 1, 1, -2, and -8. You know, that test is kind of timed. I wonder if you graph that right there and use where it crossed the x-axis, if that would help. And let's see, I'm just going to use 2 here first. All right, so I bring that down. 2 times 1 is 2. 1 plus 2 is 3. 2 times 3 is 6. That's going to be positive 4. 2 times 4 is 8, and that gives me 0. All right, so what am I left with? I'm with x squared plus 3x plus 4. Okay? All right, so are the roots, let's see, use synthetic division to find the roots. So I've got x equals 2, all right? But that one there, I can't factor. I'm going to have to use the quadratic formula. So I got x equals, that's going to be -3 plus or minus the square root of 3 squared minus 4 times 1 times 4, all over 2 times 1, which is just 2. 2 times 1. All right. And so we got x equals -3 plus or minus, and that's going to be 9 minus 16, which is going to give me the square root of -5 over 2. Well, 9 minus, oh, that's not 5, that's 16, that's 7. 7. All right. So my roots are going to be x equals -3 plus or minus I times the square root of 7 over 2. So x equals -3 plus or minus I times the square root of 7 over 2. Are all the roots rational numbers? No. 2 of the roots are irrational numbers. 2 of the roots are irrational numbers. And that's these 2 right here. Okay, those are irrational. So what are the dimensions of the storage compartment? Well, remember the width was just x, so that's going to be 2, and the length was what was 2 plus x, so that's going to be 4. The length is 4, and the height is 2 minus 1, so the height is going to be height H-E-I-G-H-T is going to be, well, 2 minus 1 is 1, so that's 1 meter, that's 4 meters, and that's 2 meters. Okay, 1 meter deep, and so on. All right, good job, folks. That's 7-1. So let's get rid of 7-1, and let's try 7-2. Finding complex solutions of polynomial equations. Write the simplest polynomial function with the given roots. Not a problem. We can do that. Let's see here. What do we got? So we got x equals 1, x equals 4, and x equals -3. So subtract 1 from both sides, and you got x minus 1. Subtract 4 from both sides, you got x minus 4. And add 3 to both sides, you got x plus 3. Okay, so these are the roots. Those are the roots. These are the factors. All right, And then x times x is x squared. X times 4 is minus 4x. Negative 1 times x is minus x. Negative 1, that's going to be plus 4. And that's going to be times x plus 3. So the next thing we want to do is we can combine these right here, and we get x squared minus 5x plus 4. And we want to multiply that times x plus 3. So x squared times x is x cubed plus 3x squared. That's going to be minus 5x squared minus 15x and plus 4x plus 12. We can combine these two. We can combine those two. And we end up, let's see, this is going to be p of x equals x cubed, 3 minus 5, that's going to be minus 2x squared, and negative 15 plus 4 is minus 11x plus 12. All right, good job. Now what about here? You got x equals 1/2, x equals 5, and x equals negative 2. That's going to give you x minus 1/2 times, and then that's going to be x minus 5, and that's going to be x plus 2. All right. So I'm going to do the back two first. All right. Say that fraction for x times x is x squared plus 2x minus 5x minus 10. I can combine those two, so I've got x minus 1/2 times, that's going to be x squared minus 3x minus 10. That's going to give me x cubed minus 3x squared minus 10x. And then that's going to give minus 1/2 x squared plus 3/2 x plus 5. And then let's see here. So we're going to have p of x equals, I can combine this and this, and I can combine that and that. So x cubed, and I got 3x squared minus 1/2, so that would be 6/2. That's going to be minus 7/2 x squared, and then minus 10x plus 3/2 x. So that's going to be minus 20/2 plus 3. That's going to be minus 17/2 x, and then plus 5. Okay, good. And let's roll it up a little bit. And you got 2i, the square root of 3 and 4. So remember, that's going to be a little bit different because 2i comes in pairs and the square root of 3 comes in pairs. So we're going to have x equals 2i, x equals negative 2i, x equals the square root of 3, x equals negative square root of 3, and x equals 4. So right here you've got x minus 2i times x plus 2i times x minus the square root of 3 times x plus the square root of 3 times x minus 4. So let's see here. Let's do these two right here. X times x is x squared. X times, that's going to be plus 2xi. That's going to be minus 2xi. And that's going to be minus 2 times 2. It's going to be minus 4. Minus 4, and I times I is I squared. All right, so we got that. And now let's do this one here. We'll do this one here. X times x is x squared, and then you're going to have plus x times the square root of 3 minus x times the square root of 3 plus the square root of 9. And then you just have x minus 4. So we can do some simplification over here. these two cancel out. I squared becomes -1. So we have x squared plus 4. -4 times -1 is +4. Here, these two cancel out, and we end up with x squared. And the square root of 9 is just 3, so we got +3. And then that's x minus 4. Well, I'm going to do the first two. The first two, x squared times x squared is x to the 4th plus 3x squared, and then that would be plus 4x squared plus 12. And that's going to be times x minus 4. I want to combine here, and I've got x to the 4th, and then 3 and 4 is 7, x to the 4th plus 7x squared plus 12, and that's going to be times x minus 4. So x to the 4th times x is going to be x to the 5th minus 4x to the 4th, 7x, that's going to be plus 7x cubed minus 28x squared, and then 12, that's going to be plus 12x minus 48. So 5, 4, 3, 2. Okay, that's already simplified. So let's go up here, and we've got p of x equals x to the 5th. Don't do that, Ron. Mr. Carbonneau, don't do that. Let me scoot that up a little bit so I don't do that. X to the 5th minus 4x to the 4th plus, and I got 7x cubed plus, that's 3. These were both positive, right? That's 4. No, that was supposed to be minus 3. So that's not plus 7x, that's just plus x cubed minus 4x squared minus 12x plus 48, because that would have been minus, so that would have been plus. That would have been minus 12 right there. Okay, so it made that plus 48. Couple little boo-boos there. Let's look at this in here. We got x equals the square root of 2, x equals negative square root of 2, x equals -5, and x equals -3i, and x equals, I'm not going to have enough room. I'm going to have to, let's just go ahead and do another one of these here. And there we go. And let's do it over. We got x equals the square root of 2, x equals negative square root of 2, x equals -5, x equals -3i, and then x equals 3i. All right. So that's going to give you x minus the square root of 2 times x plus the square root of 2. Square root of 2. And then I'm going to do these two here. So I got x plus 3i, and then x minus 3i, and then x plus 5. Put that one last. All right. So let's do these two here. And that's going to give you x squared. In the middle terms cancel out, minus the square root of 4. And then let's do these two here, and that's going to give you x squared. Again, the middle two terms cancel out, and it's going to be minus 9i squared. And then you just have x plus 5. All right, so, well, I squared, that's going to make that, I squared is -1, and -9 times -1 is plus 9. Okay, so x squared times x squared is x to the 4th. X squared times 9 is plus 9x squared. The square root of -4 is 2. So 2 times, that's going to be plus 2x squared, and that's going to be minus 18. All right, and it's going to be times x plus 5. And so we've got some stuff here we can combine. We got x to the 4th plus 11x squared minus 18 times x plus 5. All right, so x to the 4th times x, that's going to be x to the 5th. X to the 4th times, that's going to be plus 5x to the 4th. 11x squared times x, that's going to be plus 11x cubed, and that's going to be plus 55x squared minus 18x, and then 18 times 5, that's going to be minus 90. So P of x, because you got 5, 4, 3, 2, 1, 0. All right, so it's going to be x to the 5th plus 5x to the 4th plus 11 plus, and I got 11 here. 11, how did I get in that? Okay, that's minus 2, Ron, minus 2. So that should have been minus here. That makes that a 7. So that makes that a 7. So we got 7x cubed, and then since that was a negative 2, negative 2x times, since that's a negative 18, that's all right. 7x, so 7x cubed, and then 7x times 5, that's going to be plus 35x squared, plus 35x squared, minus 18x minus 90. Okay, you got to watch them signs. You saw they tripped me up twice, both of those problems. All right, solve each equation by finding the roots, finding all roots. Okay, so you can do it algebraically, but I would just go ahead and use menu331 in your calculator. So let's try that. Let's go to our calculator and go to calculate. On calculate. There it is. Menu331. The degree is 4, but this time you want, because it said all roots, you want complex. You're going to want the real and the imaginary or complex. 1 tab negative 2 tab negative 14 tab negative 2 tab negative 15. All right, hit OK. And you got x to the 4th minus 2x cubed minus 14x squared minus 2x minus 15. And press enter. And you got negative 3, negative I, and 5. So there's your 4 roots. So x equals negative 3, x equals negative I, x equals I, and x equals 5. Now what about this one here? What if we add, well, anyway, what if we add, you got x to the 4th, and we'll add 16 equals 16. All right. What's the 4th root of 16? 4th root. That's going to give you x equals 2, right? 2 times 2. Yeah. Okay. But does that give you all of them? No. That will give you x equals 2 and x equals negative 2. But there's 2 others, remember? You got, all right, so let's go over here in our calculator. Menu 331, and the degree is 4. And you're wanting all the roots, so let's go to complex, enter. And you had x to the 4th, so that put a 1 there. You didn't have an x cubed, so put a 0 there. You didn't have an x squared, so put a 0 there. You didn't have an x, so put a 0 there. And then you had negative 16 or minus 16. And press enter. And x to the fourth minus 16. Perfect. Press enter. 2i and negative 2i. So x equals 2i and x equals negative 2i. Good deal. Now, what about number 7? Again, it's just easier to go in and we'll just menu 3, 3, 1. The degree is 4. We're looking for all the roots, so we're going to include the complex. Don't want them left out. And we got 1x to the fourth, 4x cubed, 4x squared, 64x, and minus 192. Enter. And check it. It looks good. Press enter. And you got negative 6, negative 4i, and 2. So let's see here. You got x equals negative 6, negative 4i, and 2. All right. Let's try number 8. Number 8. Menu 3, 3, 1. The degree is 3. Again, you want all the roots, so we're going to do the complex 2. And you got 1 tab, 3 tab, 9 tab, and 27. And check it. It looks good. Press enter. You got negative 3, negative 3i, 3i. So x equals negative 3, negative 3i, and 3i. And there you go. Good. Let's see here. Number 9. Number 9. An electrical circuit is designed such that its output voltage V, measured in volts, can be either positive or negative. The circuit passes through 0 at t equals 1, 2, and 7 seconds. Write the simplest polynomial describing the. So we've got t equals 1, t equals 2, and t equals 7. All right. So we got t minus 1, t minus 2, and t minus 7. So that's t squared minus 3t plus 2 times t minus 7. So that's going to give you t cubed. Well, let's see. This was t cubed minus 7t squared. And it's going to give you minus 3t squared plus 21t. And that's going to be plus 2t minus 14. So that's going to give, these two come together, and that's minus 10t squared. These two come together, and that gives you plus 23t minus 14. So the voltage of t is that right there. Good job, folks. We'll see you later in class, and you have a nice evening.